Hi, and welcome to another live session of BCN that we have. So today we hope to see some basic networking commands. There are like just 10 of them to start with. I'm like, obviously there are a lot more, but I'll be kind of showing you a demo of basic ones or the few ones that you should know. Obviously some are really basic ones that you should know about, or that every internet user, anyone who uses PC or even a phone should know about, like what are these commands and how do this work. So what I'll be showing you is I'll be running these commands on two different things. One would be the Windows terminal, and another would be the Ubuntu terminal that we have, or Ubuntu terminal and Windows command prompt. For that, the tool that we are going to be using is this, the Windows terminal thing, right? As you can see over here, I've already loaded up. This is the Ubuntu version, Ubuntu running in Windows, that is Windows Subsystem on Linux, WSL. This is running Ubuntu 20.04. And another terminal that we'll be opening is the regular Windows command prompt. If you want to do, you can do it via Windows PowerShell also, but like there's no need of it. At these two places we'll be seeing few different commands that are going on, or the same commands, how they run differently on different things. Obviously not every command runs everywhere. There are different things that run here and there. We'll be taking a look at things as and when we proceed. Alright, so the very first thing first, you should know what is your identity on the network, right? So how are you identified on the network? So for that, the very first thing that you should know is what is your name, right? Because that is your identity. Now what is your name over here? On the network you do not have something known as a name, right? What you have is known as, oh, I think the text is very small. Let me just magnify that. Yeah, so on a network you do not have a name. What you have is a set of a string of numbers which are unique to you, and that is your identifier, right? So that is called your IP address. I guess, is this bit more visible now? Yeah, I think so. Yeah, this is a bit more visible now. Fine. Okay. So yeah, on a network, what is seen is, what your identity is your IP address, right? So if you want to find out what your own IP address is on a Windows thing, right, the command that you're going to type is Ifconfig. Oh, it gives you a lot of stuff, right? As you can see, I'm connected to this thing. Yeah, so I typed in Ifconfig. I'm getting a bunch of output, right? I'm something, this is my wireless LAN thing. No, I am connected to internet via my laptop right now via a wired cable. That is why you do not see anything on my wireless LAN adapters, and that is why you have the words media disconnected being printed out over here. Okay, I am connected via an Ethernet cable. That is why you are seeing Ethernet adapter having some kind of an output over here, and you have two different things, two different outputs. We'll talk about them as we move ahead. So the first one that you are seeing over here, this one, the connection specific DNS suffix and link local IPv6 address and IPv4 address, right? IPv6 we are not getting into it right now. What we are going to be focusing on is your IPv4 address. So in my local network, this is my IP address right now. This is the subnet mask. We'll talk in detail about IPv4 and subnet mask at a later point of time. We'll have a whole different set of video for that. My default gateway is 10.1.1.1 and so on. Yeah, WSL is, I am connected via my Ubuntu system, which is running inside my Windows in a container, kind of like, not exactly container, don't crucify me for that, those words that I used. But yeah, and just to give a very vague and very rough example, it is running containerized inside my Windows thing, Windows operating system. So hence that is Windows subsystem for Linux. So that Linux instance that I'm running right now, it has got this IP address, and this is its subnet mask. We can verify that, right? So what is its Windows subsystem IP? 172.24.224.1, right? Let's move over to the Ubuntu prompt that we have, and the command over there is ifconfig, not ipconfig, it is ifconfig, interface configuration, right? And as you can see, it has showing as Ethernet 0, that is my LAN connection, physical LAN cable that I connected, and L0 is the loopback. I have not connected via wireless over here, and the IP address that I'm getting is 174.24.228.28 with the network mask of 255.255.240, right? It's the same IP address, 174.24.224.1. Oh, it's exactly the same. It is slightly different over here, right? As you can see, we have two different commands, the same command logically running in Windows as ipconfig and in Ubuntu as ifconfig, that is interface configuration, right? And having two different methods or way of describing them, right? ipconfig is kind of going long in more a tabular way, and ifconfig is dumping the data on the screen in more of a paragraph format. Like few things are being shown in each line, and that's it. Okay, so that being said and done, let's clear this up for the next command that we wish to run. All right, so if you want to see more of detailed configuration of your system, or if you want to know like what is the MAC address and everything, so yeah, there are certain commands to know what is your MAC address. Now let's talk for MAC about a minute. So the MAC is your physical connector to which your Ethernet or Wi-Fi is going to be connected, right? So the IP address that you have can change and will change and does change, right? So you if you go home and connect, or maybe you're already at home right now, okay, and you do this ipconfig command or ifconfig command, you'll have a certain IP address. If you connect to a different mobile hotspot, you'll have a different IP address. So IP address will keep on changing, right? But something will not change is your hardware address. That hardware address is cooked or baked. That is the word that I wish to use over here right now. That hardware address is something which is like physically present on the motherboard of the system, be it your cell phone or be it your laptop or even your desktop for that matter. It is something which is a physical thing which is present on your motherboard, and that has got its identification in the form of something known as MAC address, and that can never change, right? So the system that you connected, right now you are sitting at home and you're connected to your Wi-Fi with some certain IP address that you have. Sure, you come to college, connect to the college Wi-Fi, your IP address will change, but your MAC address will not change. Now, word to the wise, do not give away your MAC address to anyone, right? Because there are tools available out there which can copy your MAC address and spoof them and paste it to other devices outside which you do not control, and have malicious intent or wish to do some secret or hidden activity and they do not want to get caught. So citing those security issues, I'm not going to show you my MAC address right now, because obviously otherwise you'll get to know what my MAC address, and you might spoof it and you might claim to be my laptop, whereas it is actually not my laptop. But I'll show you the command which you can run on your own at your home or on your system wherever you are, but do not show it to people on the internet. So the command that we have is something known as get MAC, right? What will it do is it will get just the MAC address of your system. Yeah, this is on your Windows thing, right? So this is on the Windows, your command is get a MAC. If I hit enter, it will get the MAC address of it, but no, I am not going to do that, right? Let me just clear this also. Okay, The command is wrong. Fine, not a problem. But if I want to know the IP address and the MAC address both at the same time in the same system, where are we? Here. Just a sec, give me a moment. So that worked. So yeah, if I want to know IP address and the MAC address associated with my all the various adapters that I have, the command that I'm going to run is ifconfig -all. Right? I'm not going to run this command again because it is going to print my MAC address on the screen, which I obviously am not going to show it to you people. Right? But you can do that at your home, ifconfig -all, and this will print all the IP addresses that you saw in the previous ifconfig command, but along with the various MAC addresses associated with those specific network adapters that you have. Right? So these are three commands that we saw: ifconfig, get MAC, and ifconfig all. And then on Linux end, we saw something known as your ifconfig. Right? I'm not worried about showing the MAC address over here because I can kind of change it because this is running a WSL, right? I have already kind of spoofed it out a little bit because this is not my actual Ethernet address, but I'm not worried about that because this is WSL. I'm not, if I was running this natively on my hardware, yeah, I would be a bit worried, but not much. I would still be worried. I wouldn't show you, but over here, not much of an issue. Right? All right, fine. So that being said and done, let's have a look at what is the next command that we have on the list. So we are done with ifconfig all. Oh, you can also write ifconfig all as this way. You can write ifconfig all like this also with a slash if you wish, or with a hyphen. Right? If you guys are having any stream difficulties right now, that maybe if you're not able to see the screen properly or like some issues, please do let me know in the comments down below if you wish. Or is there any specific command that you wish me to show you? And if I have that command available to handily, I do not have any additional packages or anything to install. And if it's not going to expose me and my PC system over the internet, sure, I don't mind showing it to you guys. Alright. So yeah, ifconfig, you can run it kind of like this. These two things. The next command that we have is, let me kind of zoom out and see my reference document. Get MAC we've done. Oh yeah, ping. Yeah, how can we forget ping? That's kind of the most second one and the most common one that is being used, right? So fine, you know that you're present in a network. I did my ifconfig thing. I know that I am connected to a gateway known as 10.1.1.1, right? With that is its identifier. I want to see that am I able to reach it or not. So I know the IP address of the location or the device that I want to connect to. Okay, I know that, but what to do now? I want to see whether am I connected to it or not, right? So the command that we are going to use for that is, let me clear this. Yeah, so I'm going to clear that, and let's have a look. The command is ping and the IP address of the system that you wish to connect. It can be a system or it can be a router, doesn't matter much, right? Alright, so ping 10.1.1.1. So what is going to happen is, my system is going to poke, if that is a proper word. My system is going to find a route up to 10.1.1.1 and return. Simple as that. It's a very low overhead packet, very low overhead thing. And the basic purpose of this is just to find whether a connection between the source and destination exists or not, right? So let's do that. Oh, I'm getting a reply, means I am connected to my default gateway that I have. So, and what all information do I get from this? So I did send 4 packets because I got 4 replies, each of 32 bytes. Yes. The time taken for it to go and come back is 1 millisecond each for each packet. The TTL is 64. We are not getting into TTL right now, but the TTL stands for time to live. What 64 is, it 64 seconds or 64 hops or what it is? We are not getting into that right now. But just that TTL is a quite important thing. If not for ping right now, doesn't matter much, but TTL in general is quite important. We can have a whole like 5-minute session about TTL later on if you guys wish, right? And so what is the statistics? I sent 4 packets, I received 4 packets, I have lost 0 packets. My loss is at 0%. Approximate round trip times in millisecond is minimum it took 1 second, maximum it took 1 millisecond. So average round trip time to is 1 millisecond. Sure, it will be very less because this specific gateway I have is present in the physical near the physical location where I am sitting right now. So if you wish to ping to, let's say, let's clear this, right? If you wish to ping to, let's say, any other location, any other server, let's say that this is this, I want to ping to this server, this is a Google IP address, right? I want to ping to it. See, now this is going to take a bit of a time because this is not present locally, right? So it goes out over the internet, it tries to find out, and if it fails, which it is clearly failing on the screen right now, you will be getting something known as request timed out. Now why are you getting multiple ones? Because it is going to send, this ping command on Windows is going to send 4 ping requests, wait for each of them, right? And what you're going to get is reply of each of them on the screen. So I sent 4 packets, received none, so my loss is 100%. I lost all the 4 packets, right? So that is my loss that I have over here, right? So doing that same in my Ubuntu side is ping n.1.1 and it just goes on, right? As you can see over here, it just keeps on going on. It does not stop. Just a second, hold on. Give me a moment, please. So yeah, we are back over here. So as you can see, I had on my Ubuntu thing. Can you get my audio? Let me check if you can get my. Yeah, you are getting my audio, right? So on my Ubuntu terminal, I just typed in ping 10.1.1.1 and it just kept on sending. Right? In your Windows, you had what? Just 4 going on by default. You send 4 packets and that's it. It terminates on its own. But no, this did not terminate on it. It will keep on going on until you manually close this process or shut this process or technically called exit this process or terminate this process by pressing the key combination of Control C on your Ubuntu system. Right? Similar thing also exists in your Windows, but Windows is like, I'll just shut it myself, I'll exit myself by sending 4 of them. Okay, so in this Ubuntu system, as you can see, it is showing that it has sent overall 19 packets. Time to live for each of them is showing as this. This is your TTL, which was 64 on the Ubuntu end that we in the Windows end that we saw, and the time taken, round trip time for each of them is mentioned over here in milliseconds. Let me just move this aside a little bit. Yeah, the time to live is shown like this. Now over here we are also shown the statistics when we terminate this process. So we have sent 19 packets, received 19 packets. There was no packet loss because we sent 19 and received 19. Total time duration was 18,029 milliseconds. So multiply that by what 1000. So you'll get the total time in 18 seconds it took to send these 19 packets and receive them. Round trip time, minimum, average, maximum, and maximum deviation. Right, so minimum time was 1.203, maximum time was 3.909. So average was 3.909, maximum time taken was 20.462. That's quite a lot of time. Right, as you can see over here, that is this packet number 10th, that took 20.5 milliseconds. Right, and maximum mean deviation or maximum deviation thing is 4.749, and you can keep going on. And if you want to see whether at any given point of time are you completely connected to a certain specific server or a specific IP address or a specific system all the time while you're streaming, like right now I'm streaming and I would like to know, I have this ping running to the YouTube server on a separate thing, which I'm obviously not showing you over here. Right, I have that running all the time so that I get to know whether my connectivity to the YouTube server, ingest server, is existing or not. If I have a ping drop, so I know that I'm not connected to it, so certain portions of my stream are not being recorded and those portions will not be visible to you guys on the screen. Okay, so that is the kind of use case for this, real live use case for this, to keep a check on your connectivity to a certain specific location, and that location would be specified in the terms of the IP address. In this case it was 10.1.1. right, so let's clear this and move on to another one.
More on what is machine learning first.
Yeah, sorry for the delay. I had a bit of network issue going on, so I was just kind of trying to resolve that as soon as I could. Alright, so here we are back in my Ubuntu thing, and you want to know, like, sure, what is the name assigned to your system? I think I have a bit of an audio issue from my end also. So let me just rearrange the mic and put it properly. Yeah, I think this should be much clearer or better or louder, I guess. But if you guys are facing any kind of issue, do let me know in the comments so that I can try and improve it for you during the next run or while I'm doing this itself. If you're watching it while I'm doing it, or if you're watching it later on, drop a comment and let me know how would you like to improve the things on my screen. Right, I'm still learning it while I'm doing it, so yeah, that's that. Learning while teaching, that's the way to go. So yeah, host name. If you want to find out what is the name of the system, name of your system on the network, or what is the name, like English alphabet name assigned to you to your system, what you're typing is the host name. It's fine, I have given a fancy name like showy offy name over here to my system and my Ubuntu thing. That's chaos. Let's see what we get over here. Host name and the Windows thing. Obviously it's a chaos. Like why? Because I assigned that name to my Windows registry. Via my assigned that name to my system via the Windows registry itself. So any terminal that I'm going to run, PowerShell, regular Windows terminal, or this Windows terminal thing, or any command prompt that you were calling, or this Windows subsystem via Linux, it is going to pick up the same thing. So the command to identify your system name on a network, the name that you are looking for is thing. But you cannot do it like this, ping chaos, right? You cannot do that, right? Sure, you can do it because I'm pinging myself. But if you do not know the name of any of the system, how on a network, how you would know the IP address of any system, right? So yeah, if you know the IP address of a system, what you can do is you can use ping and various other few ping commands that we'll be seeing in a bit, right? But what if you do not know the IP address? Let's say that you wish to connect. Let's clear this up. Yeah. To implement, I'm like, sure, if you wish to, just give me a moment. Yeah, there's a bit of a background noise going on because there are people around, which kind of ignore it. I'm trying to those mute. I'm trying few filters out over here in my streaming system to remove those noises, but I'm not being successful enough, so I'm not bothering with it. Rather, I think I'll be wasting your time with this stream. Anyways, all right. So moving on with that. So I already know my host name, right? So what next? Yeah, the thing is, what if you want to find out the name of any other system that you have, right? Let's say you want to find out the IP address. All right, so my bad. So here we are. If you want to find out the IP address of any other system that or any other website, so what do? You do not know the IP address of any other website. Let's say you want to find out the IP address of facebook.com, right? How do you do that? Via the command line. Now, I'm not asking you to go on open a browser and just type in the query like what is the IP address of Facebook. No. How do you do it? Via command prompt. So the command for that is name server lookup ns lookup and type in the full URL of the website that you wish to find the IP address of. So I want to find out the IP address of facebook.com. So there we have. So the name that is coming in starmini.c10r.facebook.com, and I'm getting two things. This is in my IPv6 format and this is my IPv4 format, right? So if I do ping 31.13.79.35, I am pinging to my Facebook, to the Facebook server which is nearest to me, which I got as a reply from the output of ns lookup command, right? So that is how you kind of find out the public facing IP address. You do not find out the internal IP addresses of any company or thing, right? This is the very public facing IP address. This way you can find out, say, let's do ns lookup for google.com. Let's see if it works like this, or do we need to type in www ahead? Okay, it works like this also. So the public facing IP address for google.com is this. What if I type in google.co.in? I'm still getting the same IP address. Oh, yeah, it's the same, right? 216.239.38.120, 216.239.38.120, right? And it is named force-safe-search.google.com. So it is not exactly google.com, it is the Google's safe search with, right? So by default it is going to remove all the explicit results from your search queries. That is your safe search. All right. So yeah, that is how you find out the public facing IP address of a certain specific website. And if you want, and then you want to say, do you have connectivity to that? And so what you're going to do is ping 216.239.38.120. You're going to get this. Okay, fine. I have connectivity, but I want to know what is my route or what path am I taking to it to reach to this specific location. That is 216.239.38.120. That is the public facing IP address of google.com. I want to know like what specific route or path the packet or my information is going. So when I type in google.com on my browser, the request goes from my specific laptop or system or PC or phone or whatever you have to that IP address. That is 216.239.38.120 over here. It goes from where, via where, how far is it? Obviously I'll not get exact information, but I can get an estimate of that information, right? So the command that we are going to see is path ping. And do you want to see path ping? Or, yeah, fine. Let's do path ping first, and then followed by the IP address. Hit enter. And now we wait. What this command is going to do is, this command is going to print out the IP addresses of the various nodes that are on the route from you to that IP address that you mentioned in the command, right? And it is not going to print out every single one. It is going to print out only the first 30 of them, right? Let's clear the screen. Yeah, so let's clear the screen over here and let's run it again. No need to type that, right? Yeah, path ping this, so that screen kind of does not keep on scrolling around. Yeah, this command is going to take a bit of time, and while we have like 5, 6, 7 entries, I'll start explaining what are these things, and after that it is going to take a few more minutes to compile the results in a bit more detailed manner. Alright, so we have around 9 IP addresses, or 10 now present over here. So this is my system, that is the originator, chaos is the 0, right? So my IP address currently, my system's IP address is 10.1.27.187. Fine. So this is where the request is originating, right? So you are the sender. The very next node is my gateway, that is 10.1.1.1. Obviously your gateway is kind of going to be the next until and unless you are in a vast network where you have multiple gateways. So that might be a whole different thing, but most of the time, whatever be the gateway address that you are getting via the ping command, that is going to be your first hop or first node. That is the node that is going to connect you to anything else on the network or the internet for that matter, right? So once it leaves 10.1.1, it goes to this specific IP address shown over here, 202.131 something, then it goes to 10.110.132 and so on. So the 12th one that you're going to see in this case is 216.239.38.120, and it is the same IP address that we wished to reach, which we know from our previous example of running the command is the IP address of google.com, right? So google.com is 12 hops away from me. That is on the whole internet architecture or the whole internet infrastructure that you have. It is 12 routers away from me. Now 12 routers can be within a range of 10 meters also, or the whole thing can expand over hundreds of kilometers. Right? It does not give you the geographical information of where of these routers are or who holds this router, who is the owner of these routers. No, you cannot get those information from over here. You can get bit more information, and that is what it is going to compute, right? That is what it is computing statistics for 300 seconds. Okay, so that's 5 minutes. Let's give it 30 seconds or 1 minute more, and if we get any results, it's good. Otherwise, we'll just terminate this thing. You can run this on your own time, so that I can move on and show you a bit more other commands also, right, which are similar to finding out the paths and the routes and tracing some things, right? So it is 12 nodes away from me. So that, right, so this is quite near in a way, I guess, but 12 nodes is near, but 12 nodes can be geographically 12,000 kilometers apart also. We do not know, right, where this specific server is physically located. You can put an estimate to it where it could be located, but if you want to get into much more detail about it, those will be certain hacking tools you'll need. Obviously those are not going to be demoed and showed over here, because I'm not going to teach you that. If you wish to learn, if you're keen enough to learn, you can learn on your own, but I'm just going to give you a brief basic start in networking commands. Anything that you do on your own is your own responsibility. I am not liable for any mishaps that you do, right? So yeah, this is going on for a while. Let's terminate this. Control C. Let's clear the screen. Right. Next command that you have is Traceroute. So this is trace RT for the route. To where? Right. So I want to trace the route to this specific IP address again. So I'm going to cheat a little bit. I went up to the previous command by the up arrow key, change the path ping to trace RT so that I don't have to type in the whole IP address again and again. And that's it. Hit enter, see what happens. Now we already know that this IP address location that we have is 12 hops away from me. So I'm going to get 1, 2, 3 up to either 11 most of the things. And if you recall, these are the same IP addresses as in the previous case, right? So what this is doing is, this command will send 3 ping packets to each, all over the path, to each and every node, and it is going to request them to give a reply. And what you're going to see over here is the 3 columns that you're seeing, first, second and third column, right? Each column that you're seeing is showing the time taken to response or time taken to reply from each specific node, also known as TTL. So I'm sending 3 packets and I'm noting down TTL, or time taken, not time taken to live, not TTL, obviously. It's a response time from each and every node that I have. So I have what, 12 nodes. I had 12 nodes, but the 0th node was me, right? So there we are. So time taken for this packet to reach 10.1.1 in the first trial was 15 milliseconds. In the second run it was 1 millisecond, and third run it was 1 millisecond. The next hop, there's 202.131 and was 1 millisecond, 8 millisecond, 1 millisecond each, and so on and so forth. Finally it reached this location, 216, 239, 38, 120. That is where we wanted to go, and time taken is 16 milliseconds, 18 milliseconds and 24 milliseconds, right? And that's it, the trace complete. This is what Traceroute does, right? Path ping gives you the IP addresses only, and the analysis below can give you bit more information about that, but that analysis usually takes a lot of time. As you were seeing, it takes at least 5 minutes to compile. The longer the route you have, more time it will take to give you the whole bit more detailed analysis, right? Similarly, we have one more command. What we can do is, we did path ping, we can do route print. Route is a whole different command which runs with like this, route print. Yeah. So where are we? there are no IPv4 routes right now. Why are we doing like that? Right, just let me clear this and run this again. I might have mistyped something.
See, I see some potential की बच्चे तब बुक भी चेक होगा से यूएस लिखा होगा टाइटल वाज वेरी नेक्स्ट टाइम करने आओ जरा बुक डिस्कस करें ना मैं सिलेक्ट अ प्रॉपर बुक
Yeah, so my bad again.
the sequence also is not good. That is because you haven't shown the presentation.
Yeah, this will print.
This is the
Oh, root print. Yeah, sorry, my bad. This is a whole different thing. So root print will print the current IPv4 or all the routing table that are present in your system right now. So there are two routing tables present in my system. That is like IPv4 routing table and the IPv6 routing table. I don't have any permanent routes. Those are my persistent routes, also known as, and these are a few of my interfaces, right? Wi-Fi direct and LAN connectors and so on. So I am connected to a few of these net destinations. With these are my network mask and so on. So it kind of gives you the printout of the whole routing table that you have. If you just want the printout of your IPv4 routing table, so you're going to do is root print -4. So it will just print out your routing table for your IPv4. If you only want for IPv6, root print -6 and so on. There are various flags available for that. Let's see. If you just type in the root, so you'll get a whole list of like, okay, this is an incomplete command and there is various few things that you need to use. So root print prints out the whole IP routing table of all kind of things that you have. Root print -4 prints out the routing table of IPv4 addresses or IPv4 routing table that you have in your system, right? The same command exists for your Ubuntu systems also. We can also do just like going back again, www.google.com, nslookup, did that. All right, this is giving me a whole different thing. We can also do your Traceroute. That works a little bit differently over here. It is giving me the same address. Traceroute 216.239.38.120. Oops, I made a typing error. So let me just do that again. It's kind of giving you the same thing, but in a bit different manner. Traceroute just finished over here. I can also do dig URL. Let me clear things for you first. Where are we? Yeah. Remove this. Alright, so google.com, I am getting few things. Let's not get into that one. We asked the question google.com with Indian location. Why? Because this request originated from India, right? So the answer that we are going to get is google.com India. That is the very specific name that you are going to get, and the related answer is going to be force-safe-search.google.com, because by default Google is going to implement your safe search, right? So we are not going to get the IP address of google.com. What we are going to get is the IP address of the force-safe-search.google.com, right? Because when you hit google.com, it redirects you to force-safe-search.google.com, and the IP address for that is going to be 216.239.38.120 right now. If you're outside of India or in some other part of India, you might be facing a different server, a different version of force-safe-search.google.com. Do let me know if you do try this and what is the answer that you're going to get, right? So that was dig for you. Traceroute that we did. We can also do similarly root. Oh, okay, my bad. I goofed it up again. Nice of me. So yeah, it just printed out root -4, just printed out the IPv4 address and that this is my current IP address that I have on my system, and there's this network mask and this matrix and so on and so forth connected by Ethernet 0. If I was connected via wireless thing, I would have WLAN, wireless LAN, mentioned as the iFace, that is the interface thing. Alright, so let's clear this up. So we are done with your how to find out your IP address, Ipconfig or Ifconfig. Then you ping is the same on both the ends. Then you have your host name, that is also done. If you want to find out the IP address of any certain specific website via command prompt, so that is your NS lookup. If you want to find out the route, if you want to find out the route that your system is going to take from your system to any other website or server, you have two options, that is your Traceroute or path ping. So that is going to give you a little bit detail. If you want to find out the routing table of your system that you have, the command is your route print or just route, and then you have few other flags available which you can use. If you want to find out a bit more detail about like who is the owner, really nice command is who is in your Ubuntu stuff. Really nice command that you have who is, and then you either put in the IP or the URL. So I want to know who is www.google.com. Okay, this is printing a bit much. Right, last update to Google is I don't want notice, no match for www.google.com. Okay, why no match found out to this? Let me run this again. Okay, my bad. Right, so where is okay, now we are getting something. Right, yeah, this is let me run this thing again, but I don't want this all heavy disclaimer because that is taking a lot of my screen and involving a lot of scrolling, which I don't want to do. Okay, so here let me see who is, simple as that. I don't want verbose, or I don't want who is URL IP. Fine, that is done. Right, so while you are at it, let's have a look. So these are the various flags or the options that are available to you, right? And what I would specifically want is I don't want the later on disclaimer to be shown. So I'm trying to find out the specific flag which disables the disclaimer, and if I find that, we'll just if I find that flag, we'll just type it in and let's see what goes on from there. I don't think I'm able to find out. Fine, whatever, just check it, just scroll it back up. So who is google.com, simple as that. That's going to give a large thing. You're fine, we can scroll up. Obviously we're scrolling up. So the domain name is google.com. It has been registered on this domain ID. Fine, register with server. Fine, you can make out a lot of other things if you want to. It was created, this domain name google.com was created and registered on 1997 9th, I think. Oh, this is the US date format, very weird, like why? So 1997 9th is the month and 15 is the date. Obviously you cannot have the 15th month, so it's the 9th month and 15th date. So on 15th September 1997 this was created at the time of 4 hours. I think that's 4 a.m. in the morning in that time zone, I guess. This registry expires on 14th of September 2028 at 4 a.m. again. Makes sense a little bit because it was registered at 4 a.m. so it will expire again at the same time a day before most probably. So if you want to contact to the registrar, the entity who registered this address on behalf of Google, so you have got these certain phone numbers and email addresses if you want, blah blah blah, domain status. You're not worrying about all those things, but you can kind of find out, okay, till what time is this certain URL registered to, and who registered it and who did it on behalf of that. So let's clear this up and let's, okay, oh my bad, I went to 300. Right, let's clear this thing and let's do this thing again for, let's say facebook.com. Yeah, let's do that. I don't want to know that, my bad. Facebook.com, there we have, who is facebook.com. And again we have this long thing. Let me scroll, please. Let me scroll. Right. So facebook.com was again registered around 29th of March 1997. Updated, this has been updated in what, 10th of March 2020, valid till 30th of March 2028 till 4 a.m. This was registered, registrar or the one who is holding this registry entry is registrarsafe.com. I have no idea what that is. You can kind of, URL is given, you can just go look it up on via browser, like what is this entity and what does it do and so on and so forth and blah blah blah. Let's check for Instagram, right, because that's the thing that nowadays people use a lot. Okay, please don't be 1997 again. Okay, so Instagram was registered on 4th of June 2004. This certificate or this URL was last updated on 1st of March 2018. Registration expires on 4th of June 2027 at this specific 1337 lead, and that's a lead reference, lead speak to those who get it. I don't know, if you don't, fine, not a problem. You can always look it up on Wiki, right? 1337, yeah, that's nice, nice date, nice number. Anyways, so that's a lot of geeking around, but yeah, you can find out like, okay, who created this or who registered this URL on whose behalf. So again, registrar safe is the one who registered this URL with this specific domain ID on this date and time, and last it was updated in this, and valid registration is valid. Information about the registrar, who is the entity who registered this, and you can always go up to, the URL is given over here, so you can go up to their website and see what they are, who they are, what all services do they provide, and so on and so forth, right? So yeah, that being said and done, let's clear out from this one also. So even that is done, who is done, dig is done, and what are we left with? Yeah, I think that covers most of it. Net start, yeah, net start, that is nice one. Let's move on to your Windows back. Net start, and see, it shows network statistics of various networks, network interfaces that you are connected to. So I am connected interface via only one interface right now, that is my Ethernet, right? So I have sent this many amount of bytes and I have received this many amount of, yes, I'm streaming right now, so I've sent this many and receiving this many. Oh, that is a weird thing. I should have sent more, received less, but anyways, I'm not getting it. How many of those were unicast, how many were non-unicast, how many were discarded errors, unknown protocols? Alright, fine. It just gives you good information about your network, or the statistics of your network interface that you have. If you don't put it with the flag over there, you'll get which protocol. Oh, active connections. Alright, so it will scan your system for various protocols that are running. So I have from this IP address 10.1.27.1.187 with this specific port number 6429 connected to this specific IP address of the external. I'm running a TCP HTTPS request, and it will print a little bit all the protocols that are running, and it will keep on scrolling. So let me just Okay, so that is done. Let's have a look. Obviously, we're not going to look everything in detail. So with this is what my local address. It will always be 10.127.